meantime, if you don't have when we mention different applications, we already imply you should know plenty of fundamental knowledge. If you miss those, you also can affect the understanding of concepts. That's basically trying to give you guys some kind of quick review. For example, I just run, this is my computer, right? Command line. I just run the IP config. You can see for currently, of course, my computer, I connect to the internet, right? You try to see. I have just a plugin. I run before I plug in their Ethernet cable. If I do not plug in Ethernet cable, this computer should connect to the internet using Wi-Fi, right? Makes sense. I also connected. You can check all those information is right there. You can see connection specific, local. That's a local IP version 6 address. Think what IP version 6 address looks like. And then check this the network card, the Ethernet network, Ethernet adapter, right? And the IP address version 6 address looks like 1, 2. You can see it kind of looks like different with IP version 4 address, right? Guys, you guys can see, right?
Yeah.
For this IP version 4 address, if it's based on the Ethernet, based on the cable here, okay, the twisted line with specific, the IP version 4 address should be 192.169.56.1. Makes sense? If back at home, please run this very simple IP config yourself. Very similar, your address will look like this 192.168.something. Okay. Then, if I ask you for this address, what's so specific for this address range? If you back at home, your address is also 192.168.something, then there could be a problem. Guys, what's so special about this address range? Last time we talked about IP address, we talked about the port number relationship, right? Right? We talked about the basic understanding regarding to the network layer, routing and forwarding. Those concepts you already know, right? So the IP addresses should look like what? If you mail a letter, the IP address should be your home address, right? Make sense? Port number should be the person you want to make sense? If like home, if you check your home, your IP address is have the same IP address, 192.168.something. Very possibly they could be the same. Do you feel some problem here? What's the problem? No.
There's no problem. They're not the same network, so they are in different networks. So there will be IP conflicts.
If they are in different network, there are no IP conflicts. Are you sure? Are you sure?
Location. No, enough.
Really? When you check your IP packet, do you see any location in your header? By your intuition, you think this IP address in this location or that location, okay, right? That's your intuition, right? Guys. When you look at this address, is anybody want to tell me what's so special about this address? Anybody? Exactly. What's private? Okay, you know it. What's private?
Private is
private. We have class C, we have private, but there are two totally different things.
Yes, because the private helps we have the private and we have the public. The public helps you to connect. Once your private goes to the internet, it's connect to the public that helps you to access the internet environment. I'm trying to
Guys, there are two really important concepts: is the public IP address and the private IP address. Make sense? So when I mail you a letter, the address needs to be what? Unique. If I have two same IP address, location in your IP header.
Okay, so what I'm saying that the IP address, because now we know the IP address allocated to probably the US and everything. So when the IP address is coming, we'll be able to know that, okay, this is an IP address coming from this particular location. That's what I meant.
So basically, actually, later on when we start this IP, guys, who remember IP version 4? How many IP version 4 address do we have? Just the formula will work. How many? 2 to the 32. Because the IP address is 32 binary bits. Then all the basic, if you list all the possible positions, it's 2 to the 32. Basically, it's not million. For gig is for 10 to the 9-ish. Okay. So although because we have the whole world, we need to connect it, right? Although it sounds a big number, that's initially we assign the IP address. We assign to different geographical location, or each being a company, we try to get a range. So this address belongs to me. Makes sense? But in that case, like in Africa, they have their authority. They will assign in China. They have, but later on, near the 2000-ish, basically the address is used back because the internet. Think about it. Oh, have to the 30, right? 32. Then you have everybody know the IoT thing, right? Then everything you need a unique IP address. Do you think it's enough? Think about how many IP addresses you consume. Okay, along the years, the number is keeping. Basically, for the IP version 4, we do not have enough IP address. Make sense? But in order to do the routing part, we like mail the letter, the address. If you want to route outside, they need to be unique. Make sense? Otherwise, one mail letter, I have no idea. Oh, I need to figure out should this one to Houston or this one to Dallas, they have the same address. It's confusing, right? You need to differentiate. Make sense? That's why. But in order to resolve those problems, like we do not have enough IP address, we create the private address concept. But the private IP address, we kind of allocate the few, areas, assign them to called the private address. But that private address, you cannot route it to the public internet. Make sense? But like your home, you very possibly using this range. But in your home, think about your home, you need really quite a few IP addresses, right? In my case, I have 2 kids. I have my computer, my husband has a computer, my 2 kids each, they have if they no computer, they don't know what to do, right? That's the reality. Then they have their phones, right? Then they have plenty of I have my iPad, everybody got their pad. You can think about it. You don't forget about the things, right? Make sense? Then each one of us got some kind of like 192, 168, got something, right? But when the packet routed out, how many addresses do I have if you use the local SP assigned to my family? Only one. Make sense? Only one. When you send it out, in that case, my local router, when we try to access the internet, you need to do some kind of conversion. You need to convert this private IP address to the public IP address. But we are breaching the boundary between the transport layer and the network layer. Remember, last time we also talked about the port number, right? Right? How many port number do we have? Later on, when we talk about each purpose, the field, right? Port number is only 16 bits. In that case, port number we have 2 to the 16. But for TCP and UDP, you have 2 sets of different port number. Makes sense? So we are breaching the IP and the port number, those boundaries. When I send it out, my kids are sending it out. From outside, we all have the public IP address as it assigned to our home. But we change the port number to different port number. Make sense? But inside, we look like this. But this IP address cannot go outside. You guys got it? In that case, it's like you have a public internet, but you have plenty of private island. In that private island, everybody using a few IP address range. We can using that address again and again and again to resolve those kind of we do not have enough IP address, version 4 address problem. Got it, guys? Now this one, like a lot of math, you know this IP address from
16.
here, you or it's in my home. It's hard.
16.
Okay?
Yeah.
Then that's the first thing. We will later on have time to talk about. But I'm glad you mentioned, like we have
Yeah, 32 for IP.
You also mentioned there's a little
32 for version 4.
So then, for this network, card-wise, internet, right? My IP address is 192.168.56.1, right? This is if you change to the binary. If I ask you, what's the binary version of this IP address? You guys should know, right? Basically, just 192 should be what? 128 plus 64, 11 followed by 60. So on and so forth, makes sense? This is called the dotted decimal notation. This number will be just exactly, you can convert it 32 binary, 32 0 and 1. Makes sense? Okay. That's IP version 4. Then the next one you will see have a subnet mask, right? What is this for? Subnet mask in that case is 255.255.255.0, right? What is this for? If I have a binary n, a and b, of those two numbers, result?
Oh, that would be 11111111 ellipsis and 000.
What would be the result of the binary end? Guys, what is end? 1 and 1 equal to what?
Oh, okay. That's only two pieces.
1 and 1. Just the 1 digit. 1 and 1 equal to?
And 1.
1 and 0.
0.
0 and 0.
0.
Okay. So in that case, 1 and any binary variable equal to? 1 and binary variable. A could be 0, could be 1, equal to?
A.
Okay, thank you. That's the basic foundation. 0 and A equal to? 0 A. Okay, change the bad binary, binary variable. Make sense? If 1 and that's binary variable, so still is original. Make sense? If 0, change to 0. In that case, the first number, 192 is what? 192 is a 11 followed by 6 zeros, so on and so forth, right? 255 is all 8 ones, right? Then all the ones and the previous number, does it change? Still 192, make sense? Then 255 and 168, still 168, right? Then the third down to decimal part, third byte should be 56, right? Only what happened to the last byte should be 0. Makes sense? Because it's 8 zeros and it will 0 out. Got it? So in that case, what is the subset mask here? Basically, we just want to, in this case, if the subset mask is 255.255.255.0, we just want to get the first 3 bytes out. Make sense? Got it? Yeah. So what is first 3 bytes here? So for each IP address, okay? For each address,
Did you get it?
32-bit, right? Make sense? You can put the 32, stars there. And the dotted decimal notation. For each IP address, we have 2 parts. One part is associated with the network part. We call it net ID. The second part is related to host. Got it? So in that case, if I have another IP address, it's a 192.168.56.10. This network mask, those 2 IP addresses will belong to what? Same local network. Make sense? Because their network ID is the same. Got it? Got it, guys? Of you? That's basically when you're doing this, you need to know what is the corresponding IP address, what is the network mask. They tell you, based on this, if they share the same network ID, everybody needs to have a unique IP address. Even with private, in the local area network, private IP, you also need to do the same. Make sense? In that case, they need to know whether they fall into the same network. Okay? Got it? This is checking the network ID part. Okay?
Oh, explain that to me.
And if you check this part, this in that case, my computer, because we have 2. Another question is that if you have your computer, right? If I ask you for any kind of computer, how many IP addresses do you have? How to answer this question? How many IP addresses do you have?
Does that one you have like a bunch of like ones and zeros? I don't know. I'm just
From this conversion,
for both of these. Like this is full of 1. This is like 1 1 1 1 1 1 1.
For my computer.
1 1 1 1 1.
Also, there's 256 times.
This is the max. Yeah.
Then if I ask you how many IP addresses do you have, you basically
It's like I think
associate
1
this
1
one.
1 1 1 0.
Yeah. Okay.
So for each one is this.
Associate
Yeah.
what? one
zero.
network.
So
It's gonna zero out.
yeah, because this one
In your
is zero.
in this
If you multiply these two values,
Yeah.
my internet
binary is gonna be zero. One times zero is
IP
what?
address.
Zero.
Yeah, so you would get
So
zero.
if you turn on my
So the
Wi-Fi,
last would be
So it's
zero.
like ended 1 times 0 0.
Yeah, they're ending basically. Here, you're full of ones. This is one.
So in that case, if I
It's gonna be like zero, zero, zero,
it will be a sort of only network interface.
And this is like a bunch of 1.
Yeah, it's a bunch of ones, so you can multiply and still get one out of that. So you would get
Okay, another thing, currently, if you check on my current situation, I'm using the Wi-Fi to connect to the internet, right? Because this is, I have the gateway. That's basically the, see, for this Wi-Fi part, the network address is 10.32.183.198, right? Then,
one times.
you see the network mask is slightly different, right? So how many bits is allocated for the network IP part engine for the Wi-Fi part?
168. 1 times 8 is 90.
1 times 8.
Here,
This is 8. This is
you should in your mind imagine changes from the file
The reason why
to change this
because next
decimal number to the binary number, right?
1
255 will,
and it's
oh,
binary.
it's comments.
Okay.
Basically, I think that's what you're trying to say. Like, if there's one, at least
In this
one
case, 255 is equivalent to 8
binary
ones.
code.
Second 255, 8 ones. Third is 254, basically 7 ones plus a 0.
So basically,
Make sense? If you're doing the AND part, how many ones basically associate your net ID part? In that case, your network ID is not 3 lines. Instead, it's what? 8 plus 8 plus 7, right? Make sense? It's 23 bits. Then you left 9 bits for the host ID part. Make sense? That's basically the boundary. It's slightly different with that internet part. Because the subnet mask basically tell you what? There is a boundary between the net ID and the host ID part. Got it? If you double check this is your gateway, remember, your first gateway is your router. Then through that gateway, you route it through the network, right? Your check, they belongs to same network. Basically, the net ID part, if you're doing binary and they should be the same. That makes sense, guys? Because somebody told me you need some hands-on. That's basically if somebody check a little bit the network part. That's everything's there. Just you need help. Okay, I will give you a little bit of information, some kind of background. Later we have a little bit more stuff there. Okay. You guys make sense now? So basically this is a workshop I asked you to download, okay? So I just cached some kind of trace, okay? So see, in this case for this package, let me change it. For example, for those how many packages I already stopped, how many packages I just cached how many packages like 90-ish. You will see this is the source destination source IP address to the destination IP address, right? This is the source. Somebody I guess I opened the what Google, yeah. And this is the source IP, destination IP, protocol is TCP. And if you check the details here, so you have the frame. Let me change it. This is a frame packet that looks like. Okay. Then later on, frame header is followed by what? This is IP version 4. Okay. Then followed by.
this is maximum.
This is Ethernet frame. Then followed by the TCP. That's the TCP is segment looks like. You have what source port, destination port, signature number. Okay. I just put this kind of option out of you guys to see each packet, what does it look like, what's the field looks like. Okay? Actually, I remember you can change this. Later we can cache these together. I will just close it down. Not going to save it. Without saving. Let's get those kind of old slides out. But for the bar chart, if you're doing some kind of it's like a packet sniffer, right? When you turn on the download, it's free. Download the bar chart. When you open some web page doing something, you can start catching the tricks. Okay, then after a little bit you can stop it. Then you can see what kind of package you catch. Everything is there. Most of we only learn the tiny part of those kind of protocols there. You will see plenty of many other protocols right there. Later we can do this. But before we give you guys a little bit IP part background, okay? Consider just you guys need that background, otherwise it's hard to. For some part, if you guys already know, we can quickly pass. Okay? Okay? Just for the concept wise. This is from another book. That book, I also teach internet design class. That book typically I use to teach internet design. But I haven't used that course for a while. So that means that slides might be a little bit old. But the concept is the same, okay? These slides, everybody is familiar, right? 5 layers. Makes sense? For each layer, how do we call those, what are the packet streams there, right? Message, segment, IP, datagram, then frames. Makes sense? Those 5 layers, okay? Then, talk about the layering concept. Each layer, when we actually sending out the packet, each looks like application layer is talking to application layer. Makes sense? Transport layer is talking to transport layer. Looks like. But in reality, we already know the packet flow, right? Yes. Actually, all the information is from the top all the way to the bottom, right? Then 0 to 1, you send it out. Okay? That's one local network. Then you go to the router part. Router still need to check, read what your network header, right? That's why router only basically handle to network link. They don't know what included in the network, but they need to later on. The information need to flow up. They need to check what's in network header, right? They make the decision. Then they re-put the new header in there, make some few changes, put the new frame header in there, then they resend it out. They may go through this different router multiple times until they reach the destination network. Then eventually, if this reaches your destination network, all the information will flow all the way through the application. Your destination application actually received the whole package. Makes sense? We already covered this concept. Only this part. Even I mentioned this part, any question? Fine, right? But it's layers, but from the surface wise, it seems application we are start chapter 2, right? We have client server and peer-to-peer, right? When you have any kind of app, seems like your client is directly talking to the server. But in reality, they need to go through this whole thing. Makes sense? That's basically one key concept I hope everybody knows. Then we have a kind of 2 boundaries here. So when you actually, for example, you're programming for a new app, right? You only first has a few parameters. So you have one boundary is many of the function applications handled by what? By operating system. You're possibly only doing the application layer part. Make sense? That's one boundary. Then I want you to actually think is the IP address? Because we have another boundary related to the IP address. When we actually send it out, from 0 to 1s, right? Do these IP addresses play a role in there? From one hop to the next hop, from the physical layer. From the physical layer and the link layer, do they know what is your IP address? Yes?
No. Everything is encapsulated into converted to one and zero, which is how it is coded.
Yeah, 1, 0, but the IP address could also be 0 to 1, right? But when you actually, the packet is transmitted through those, right? Actually, you send out from one hop to the next hop. That's the IP address play a role? No. It's based on what? Your hardware address.
Oh, okay.
Makes sense? And when you send it out, think about your MAC header. The IP address is not there. When you actually send, for your router, I received this packet. I repacked, a destination address never changed. But based on destination address, I know what will be next hop. I need to put the next hop's hardware address in the new frame header. Then when you send it out, who will receive it based on that MAC address, your hardware address. Make sense? So in that case, you see the boundary makes sense. So IP address actually is what I get. So here, the user's contact is the IP address in different location could be different, right? So when your computer moves to another room, when you redo the IP configure, it's a totally different IP address, right? When at home, it's another. Does it make sense? So what is the IP address? IP address is a kind of it's a software thing. Got it? It's basically assign your address to help you to do the communication networking. It's not exactly social with your network, actually with your network internet. Not like your MAC address. Got it? For the IP address is just for the whole network, assign your IP address in order to connect to the internet. Got it, right?
I think though, in home, if we have different devices, we have different IP addresses, right?
So it's like
If we have, I'm asking, in a home, do we have different IP address for each devices or just for one? For a particular location, just one?
Who will help me to answer this question?
You have one IP address for the home, but the MAC address might be different.
For example, I talk to you, right? In the home, I have another student. I want to talk to you, I need to say your name, right? Makes sense? Yeah, that's your IP address. If I want to talk to another person, she has her name. That's the IP address. Every time I make the communication, each network, different network interface. If you want to connect to the internet, you need to have a different IP address. Of course. Yeah, makes sense, guys? So IP address is more like a software kind of stuff thing. That's basically you look at the boundary part. So only about the link layer from the network layer, transport layer, kind of know what is IP address for. If you're lower, it doesn't make sense, right? We are not based on IP address to make the communication. Got it? I hope in your mind think about those kind of two boundaries here. Okay? Because later on, after this is more like a link layer part. Actually, communication, they are not based on the IP address. Okay, got it? Then, we also mentioned the different layer. We have a port number. Guys, this later we'll look at this. What does this mean? Basically, for example, this is your client and server. This is more like a chapter 2 stuff, right? So, client want to talk to the server, okay? In reality, this is what it looks like. You have a kind of physical channel. Could be Wi-Fi, could be wireless media, okay? Could be you are connected using twisted Ethernet. Could be any kind of medium. Basically, your client wants to talk to the server, right? You have a physical medium link the client and the server. They need to make like I'm talking to you, right? That's the case. But in reality, because we have layer for the client part, we could have what? We could have a C. We could have all kinds of different applications there. I put like a SMTP. We have HTTP browsing, DNS domain name service, DHCP. If every time, guys, when you join this here, join a new network, typically they will automatically assign your IP address, right? It's based on using what DHCP, right? That's basically tell you all kind. SMTP is for what? For your email, right? You might be using all kinds. Just a few examples. You might be using all kinds of different applications there. Make sense? For each different application, typically they are associated with what different processes, right? Make sense? For each processes, how to identify each different process is what? It's port number, right? In that case, for your email, typically it's based on TCP, port number 25. DNS should be based on UDP, port number 53. HTTP, server side should be TCP 80, right? For your client side, it's your operating system assign your random port number, right? Later on, play the workshop, you can check your port number is pretty big, okay? It's not a popular port number. Then, that application layer, message, right? They move down to the TCP, got it? Right? Some is move down to the UDP, if they are based UDP. Then everything move down to the network layer, right? If you are using the IP version 4, although IP version 6 is there, but the IP version 4 is still dominant, okay? IP version 4, okay? Got it? Then we got each frame. So in that case, you send it out. For the client side, we have a multiplexing concept, right? Right? No matter which app, which thing you're playing, you will only have one physical medium. Right? The network internet, for example, Wi-Fi or the Ethernet. Then you send it out. Okay? Then the receiver receive all the different packets. They need to remember, initially you put the onion rings layer by layer, right? When you receive the receiver, you kind of remove the onion rings layer by layer. Then eventually deliver to corresponding different applications on the receiver side. Guys, make sense?
Yes.
Got it? That's some kind of a big picture. Reality, this is what happened. But it goes through those kind of check in the header, you know, thing. You go through different layers, okay? Add the header on the receiver side is remove the header thing, okay? Fine?
So at the host, it uses the port number to know the particular
Port number is a transport layer thing. Then the port number is associated, also closely associated with your different application and the processes. Think about it, even that's why I'm asking, remember my question, how many IP addresses do you have? Different app, for example, you're only using the Wi-Fi to connect to internet. No matter which app you're using, they all using the one IP address and get out. But we have different apps there, right? How to differentiate? Port number, get it? Then of course, using the TCP or UDP, later on for we have a little bit more complicated regarding to the socket, because still remember the socket thing? How the socket is slightly different. But you kind of at least know different apps, they have different port numbers here. That's why even we have different person living in the same household, right? They are still living in the same house, same IP address, right? This is what Sharp is what for, okay? Basically, it's just to get all those, it's called a packet sniffer. They have, we call the packet catcher, okay? Please download, it's free, okay? Then you can basically, when you play the different, when you go to different websites, when you're doing different things, they will catch the trace, you will see what's the corresponding header in there. Basically, I bring my computer here for a reason because I'm not a mean for this computer. I cannot play that for that computer. Makes sense? I can play my computer. This is for your case, same thing. When you do this, you can check, okay, we are learning HTTP. Then, of course, we have so many HTTPs packets there. In reality, if you actually download those trees, okay, in reality, HTTPS is more popular. Okay, many websites is using HTTPS. Then you will see for HTTPS, they are not, for number is not 80, it should be 4 something, okay, 400 something. Okay, so what kind of product actually is there? You'll see plenty of new names in there. We only learn a tiny subset, but you need to know the concept. Make sense? That's basically the PCAP. Just catch all those packets and help you to analyze what kind of packet is going through when you're doing any kind of stuff. Okay? You can quickly read. You have questions. I will explain. Okay? For IP version 4, I kind of using IP config because I already kind of understand for IP version 4 address, right? And also one thing I want to mention is remember the boundary. The IP address is the only network layer and above know what is IP address for, right? Right? So in that case, what is you can think of IP address is like kind of like a group. It's more like a put is like internet is abstraction. I assign different IP address. We can see we have different network to put the network together. Make sense? But it's kind of it's abstraction. It's a software thing. It's not a physical address there. Every time you have different network, you assign different IP address. Make sense? This is one of the keyword I want you guys understand a little bit. Because when we think about the internet, we always think about, the internet is pretty fancy, right? It's one network. We all know that the internet is more like a network of networks, right? But from the illusion wise, it seems like one network. As long as you connect there, you can do plenty of stuff, right? And how to achieve those? In order to achieve those, achieve a seamless communication system, powerful software must hide all the details. IP is one of the important concepts, hide all the details. Actually, from physical network, what's each your destination's physical map, actually you have no idea, right? But actually communication, you eventually need to know the physical MAC address goes through each house there. That's basically it's a kind of hiding there. It's like illusion. Then you can achieve those internet kind of functionality. Make sense? Then in order to understand those, you need to understand the basic IP addresses, like I already explained. We have each address. We have two different parts, right? And they are
private and public.
That's the two different IP addresses. For each IP address, we have two different parts. We may have for each IP address, we have what? Net ID. This part is associated with network, which network, and we have host ID, and this boundary could change.
Okay.
Make sense? And regarding this boundary, what's his name? He mentioned what's your name? Apple. So he mentioned the class C, right? Then somebody also heard about class A, class B, class C, right? Who heard about it? Who heard about CIDR? That's why we need this class, right? Okay, we'll go on. So those are some things we need to kind of understand. Okay, that's why we need this class. Addressing part. Address is important. And all hosts, the computer must have uniform addressing scheme, right? We were using IP version 4 as an example, 32 binary bits. And each address needs to be unique. Even though you have a private IP address, but private address cannot go outside of your local. If you go outside, you have no idea what this address for. Makes sense? If you go outside, they need to have the translation part. Okay. Then what is a MAC address? And the MAC address cannot meet that kind of those because what? network card inside in there, right? It used to be separate, now it's getting smaller and smaller. That MAC address typically is already settled. Of course, different technology could be different. Put some still dynamic. But point here is how different technology, the MAC address definition, how to assign is different. Okay? But by using the IP address, we provide what? Provide kind of umbrella in there, right? Then each IP address looks kind of like similar. Makes sense, guys? How the node boundary concept now, right? MAC address and IP address. IP address is network layer and up using what? IP address. And network layer and lower using what? MAC address, right? IP address is kind of a software thing, okay? Not the hardware thing. Then talk about IP address. 32 bits, right? Then for typical IP version 4 datagram, it looks like this. Will play function, it looks like this. Okay? So you will see how many rows we have here. This one is option. Forget about this last row, right? How many rows we have? 5, right? And each row is, if you check from bit 0 to 31, basically each row is 32 bits, 4 bytes. Okay? This is a typical IP version 4 header. Okay? So in that case, if I ask you, Andrew, how many bytes for IP version 4 header? Look at this. How many bytes? How many rows? 5. Each row is 4 bytes. How many bytes? 20. You guys know, typical IP version 4 header, we have 20 bytes. Okay? And this option is not data buffer typically. Makes sense? If we need option, we will have option. But typically, we only have the first 5 rows. Okay? Then in that case, for now you get the format. Anyway, version part. The 4-bit for the version is tell you it's a version 4 or version 6. Makes sense? Of course, it should be version 4. Header length. Okay? Okay, we will explain those later on. You guys heard about this, right? This is associated with what? To avoid what? Start this class, we have one. You guys remember trace route? You guys remember the trace route part? The video part, right? It basically shows you what? The hops along this process. Make sense? So I just remember I like Yahoo, right? I'm still trying and just trace route Yahoo.com, okay? So in that case, what's happening here? They will go through first. So based on this information, you guys still remember my IP computer? I have 2 net ID, but I'm happy because I connect to Wi-Fi first. Still thinking about Wi-Fi. That's basically because you see the first hop should be what? Should be the gateway, right? Makes sense? It still belongs to Wi-Fi network, okay? Then next hop, so on and so forth. So later on, some of the route will get bored. They will not get this information. You guys still remember how do we get this trace route information? You guys remember? Who remember? Nobody? The reason I try to 255. In that case, every time you go to a hub, router will reduce it by 1. We will avoid the packet will stay in the network forever. Make sense? Because sometimes when you're doing the routing, when your routing algorithm is wrong, it will stay forever. You have too many signals. When it reduced to 0, packet will be jumped. Remember this, that's a TTL. That's typically each router. Remember, when we talk about delay, router need to process the packet, right? And the reduced TTL is one of the functions they need to do. That's a typical case. So what's this doing is, when I send out, remember, it's based on the SMP and on the protocol. What I'm doing is I send out 3 packets. Those packets is the TTL I set, first 3 packets I set is 1. Okay, then you reach the gateway, reach the first router, the TTL reduce to 1, then it will drop the packet. Make sense? When you drop a packet, it will trigger SMP, generate the error message. Then I can get a timestamp. I got what's the time delay there. Then as the second 3 packet, I set TTL to be 2. Make sense? Pass on the first router, when move the second router, reduce to 0, generate automatic because it reduced to TTL is 0. They need to drop the packet. Then you have a generate SMP packet. I got the information. Make sense? That's how the trace route is working. Got it, right? Point here is then TTL. You know what is TTL do now, right? Okay. I'm about to see is because remember I talked after we got this background, hopefully things will be a little bit easier. That's basically for this. I'm talking about the reason I show this. I need to switch. I need to stop. This basically all those 20 bytes is a typical IP version 4 header. Okay. So initially version 4, what's the length? It should be 5 because the 5 is based on the multiple of 4 bytes. Typical, if you do not have high-end options, you have 20 bytes. It's 5 of 4 bytes. Makes sense? If you read IP version 4, you will see first is 4, 5, so on and so forth. Some is used for the QoS, yes, differential equation, the total length. Second row is for fragmentation because we have a different network. Each network, the required length could be different. Make sense? Make sense, guys? If we are using the Ethernet frame, they have a limited length, how long the packet should be. Then you move on to another network, the maximum length, if it's shorter, you have to break the original packet into 2 packets or multiple packets. Makes sense? That's the second row for. Okay? The third row is a TTL. You guys already mentioned. I explained, right? Time to leave. This is protocol means what? You guys remember our quiz, right? Yeah. When the packet move down from application layer, right? Application layer to the transport layer, you add the transport layer header, right? Then move further down, you go to the network layer, add the network layer header, right? We are currently looking at the network layer header. Got it? Got it? But what's inside? What's in the payload? So they could be different transport layer stuff. Could be TCP packet, could be UDP packet. Make sense? So this protocol basically tell you what's inside your payload, what's your transport protocol you are using. That's from that protocol. Basically tell the information there. Make sense? Then the header transfer is trying to do it a little error correction kind of capability there. Okay? Then after all those, 2 major things in your IP header is your source IP address and destination IP address. Make sense? Okay. So because why we kind of arrange each row is 4 bytes because the source address is 4 bytes, destination address is 4 bytes. Make sense now? Yes, got it? This is if I ask you, so typical IP version 4 header is how many bytes? 20 bytes. What's the key concept in there? At least not, I didn't explain a lot, but at least you have a basic idea now, right? So remember, we want to play the address, we want to play the packet format with that's some kind of basic information. This we can pass, right? Then we already explained for IP address. Although 2 to the 32, only 32 bit is not enough for us to use, but it's still a big number, right? Makes sense? In order to the network is a huge network. In order to maintain, how to design a routing algorithm, how to design a value in the same network. That's why we have IP address hierarchy. We have two different parts. We already explained, which is the first part is the net ID, right? The second part is the host ID. If the net ID is the same, we'll say this belongs to this network. Make sense? For the net ID, we also call prefix, okay, different name, or net ID, okay? It's kind of identifies physical network to which the host is attached. And each network in the internet, in the internet is assigned a unique network number. Make sense? Okay. Same, because in order to route it through the public internet, your IP address needs to be unique. Okay. Then the second part is the host ID. That's all the possible name. Could be suffix, host ID, whatever, as long as you know the second part. Okay. In that case, the host ID is specifically identify a specific computer, or specific, to be exact, to be what? A network interface. That's more exact. Makes sense? Okay. So you kind of understand that the beauty of design is the hierarchy. You have net ID and the host ID, right? Make it a little bit what? More organized. Otherwise, if this is scattered around, when you design all those routing algorithms, although the location information is not in there, but because this network is located in Houston, it's implied, but not in there, okay?
I know.
Okay. So in that case, guys, for your total IP address version 4 is 32 bits, right? Your total IP address is 2 to the 32 different IP address, right? So in that case, like we mentioned, we could have a type A, type B, some kind of class A, class B, class C address, right? So in that case, so how should we put the boundary in there? Make sense? So far, this is your IP address. We need to have a boundary. First part is your net ID. Second part is your host ID, right? Then where should I set the boundary? If I set a boundary, what does it mean? You guys think about those, okay? That's basically related to original classes of IP address. The boundary at the first byte. Makes sense? If we set the first byte, in that case we have you see the first row, right? Class A address. In that case, what? We have 8 bit is assigned your net